24 Death Stars tracked heading towards our solar system. And this is the one that is supposed to be the closest to us. There is a fleet of Death Stars coming towards Earth. Some 600 are set to blunder past, bringing an icy hail of destruction. This is by Jamie Seidel on news.com Australia. There's a Death Star heading our way, bringing with it an icy hail of destruction, but there's still time to linger over our Star Wars sequel, or 300,000, and it's not the only one. There are up to 24 such Death Stars, quote-unquote, likely cut within 3.26 light years of our solar system. Another 600 could blunder past at 16.3 light years, all close enough to topple distant comets down the gravity well towards the inner planets, that is, including us. Comets are huge. Now, fresh research from the Max Planck Institute for Astronomy used data collected by the European Space Agency Observatory Satellite Gaia, ESA Gaia, to update his calculations of how many wandering stars are likely to stumble into the Oort cloud, an enormous bubble of rubble that surrounds our sun, and how often. Dr. Corinne Baylor-Jones found that within a typical million years, between 490 and 600 stars will pass the sun within a distance of 16.3 light years or less. Some 19 to 24 stars will pass at 3.26 light years, that's 1 parsec or less. But don't rush out to buy life insurance just yet. The earliest close encounter is still hundreds of thousands of years away, and it will possibly take tens of thousands of years more before the fallout of its passing comes our way. Impacts with regional or even global consequences are exceedingly rare. When we're talking about hundreds of thousands of years, okay, if you put into that timeline the fact that 640,000 years ago we had the major super eruption, the last super eruption at Yellowstone, that's not that far away, these Death Stars. So the earliest close encounter is still hundreds of thousands of years away. It will possibly take tens of thousands of years before the fallout of its passing comes our way, that is, all these comets it's bringing with it. Impacts with regional or even global consequences are rare and occur at a rate of no more than 1 per million years, Dr. Baylor-Jones says. So that's bad enough, I would say. But anyway, he says also monitoring systems give us a fairly complete inventory of larger asteroids and comets, none of which is currently on a collision course with Earth, from what he knows. Prime contender, an earlier paper published in the journal Astronomy and Astrophysics by Baylor-Jones, detected 14 wandering stars that will pass within 3 light years of Earth. To put all this in perspective, our closest neighboring star is Proxima Centauri, a red dwarf star, and that's some 4 light years away. We do have a red dwarf star at the end of our solar system. NASA has confirmed this. Now, Baylor-Jones tailored his initial study to include all 50,000 stars upon which we had accurate fixes, quote-unquote, for that time, including their distances, directions, and their velocities. Data collected by the Gaia satellite has since considerably expanded this data set. And while the number of Death Stars has since been almost doubled, HIP 85605 remains the most likely to become our first and closest encounter. The wayward orange dwarf star is on an intercept course with our solar system. Odds are as high as 90% it will crash into our Oort cloud sometime between 240,000 and 470,000 years from now. That's bad news. It's currently 16 light years away, approaching us from the direction of the Hercules constellation. It will likely skim past our solar system at a mere 0.13 to 0.65 light years. That's roughly 8,000 times the distance between the Earth and the Sun. That's not that far away. because you're talking about another sun. Another seems close behind. The star designated Gliese 710 has been calculated as having a 90% chance of coming within our sphere of influence, currently lurking some 64 light years away in the Serpens constellation. Is expected to land in our neighborhood sometime between 1.3 1.5 million years from now. That was the second last super eruption that we had at Yellowstone, if you remember. Now, he says, going on with this, we've already experienced a near miss. The white dwarf Van Manen star, fortuitously a burnt-out star, came close to our sun about 15,000 years ago. Exactly what impact its passing had on the Oort cloud is as yet unknown. Hit and miss? In the face of a fully armed and operational Death Star such as HIP 85605 or Gliese 710, Admiral Akbar would rightly say, we, quote, can't repel firepower of that magnitude, end quote. Stars are impressive, they're big, they're fractious, they're thermonuclear. Even our own sun, a somewhat humble small specimen, can cast worrisome clouds of superheated superheated plasma our way. It may sound like an interstellar game of billiards, and in many ways it is. But even when they arrive, Swinburne University astrophysicist Dr. Alan Duffy says not to expect being swallowed by a star. The scale of things is simply too great. Instead, the threat will be what happens to the masses of comets orbiting our own solar system outskirts and out as far as 1 light year away. He says objects hardly ever meet in space, the distances are so large, but the gravitational influence of a star is enormous. Even something a light year away can rattle the loosely held Oort cloud objects, Dr. Duffy says. But there's no doubt that nearby stars in the past have nudged Oort objects into falling towards the inner solar system and towards Earth, of course. So the real questions are we really in the firing line? What is being fired at us? And what are the chances of a bullseye? We're fairly safe down here. It's taken millions of years, but Jupiter has managed to clean up most of the inner solar system by pulling wayward comets and asteroids into its heavy embrace. But it is a fragile balance. Those distant tumbling mountains of rock and ice can be sent wobbling towards us. The fear is Earth and all the inner planets could be subjected to a bombardment not seen for millions of years. Death Star gamma microscopy, HIP 103738, appears to have already drifted to within a light year of our sun by 3,850,000 years ago. There are 2 impact craters on Earth that could possibly be attributed to this event. Bake and shake. If a Death Star was a hot one, could its powerful UV radiation be added to the planet-killing arsenal it unleashes? Such radiation could tear apart the DNA of all living things once our thin line of defense, the ozone layer, is stripped away. As Dr. Duffy says, it would have to get extremely close, impossibly close for its radiation and gravity to have any direct effect on our planet. Gamma microscopy, the G7 giant, which whizzed past some 4 million years ago, is believed to have been about 2.5 times the size of our own sun. Its radiation is not known to have had any effect on our world. He said none of the stars that will likely come close to us are particularly large or bright, meaning that they won't affect the Earth with their UV or heating directly, he said. A star 100 times more luminous than our sun would have to get as close to Earth as Jupiter for it to be brighter than the sun in our sky. If it's a smaller star, then it would have to get even closer. Long before then, the gravity of this intruder would already have likely flung the Earth out of our orbit. Thankfully, no star is predicted to come that close. We're always talking about what they've found so far. It doesn't mean that they have found everything. Supernovas. Each Death Star will take about 30,000 years to pass through the Oort cloud, our Oort cloud. We will remain in their spheres of influence for tens of thousands of years more. There is a remote chance one of them may reach the end of its life cycle and explode during that time. Baylor Jones says, we see radioactive isotopes on Earth which point to nearby supernovas over the past few million years. But Dr. Duffy points out the odds of one of these stars exploding when close enough to have any impact, and that means within several light years, is infinitesimal. He says, however, the main reason is not that is not a worry is that none of the nearby stars that are drifting towards us from this study are big enough to explode as a supernova, he says. But but these stars have a typically imperial problem, accuracy. And by the time the first of these Death Stars arrive, our race will either already be dead or so highly evolved as to simply not care. While a direct collision by a large comet would be a disaster for the Earth, we're actually a very small target, Dr. Duffy said. A much bigger target is the gas giant Jupiter, with an enormous gravitational pull that attracts the comets and cleans up the solar system. Yet even Jupiter is tiny on that scale, so it's much more likely that any comets that tumble in towards us will just pass harmlessly by. Time is on our side, he says. Even if these stars did tumble any Oort cloud objects out of orbit, these could take up to 2 million years to drift into the inner planets. Many of the stars set to cross our path are dwarf stars smaller than our own. This means the potential influence that they may have on our Oort cloud will be limited. We can get more Boltzmann-like data without the casualties right now. Instead of R2-D2, the carrier of such secret plans would be the European Space Agency's Gaia telescope. It's helping pinpoint the tracks of these deadly interstellar bodies to determine how many are on the way and which ones may have done us damage in the past. It's currently cataloging over 1 billion objects in our interstellar neighborhood. The Gaia satellite is currently in space, creating the best map yet of all the nearby stars, allowing us to know to great accuracy just which of the billions of stars in our galaxy will likely ever get close enough to cause us problems, Duffy said. Even though the galaxy contains very many stars, Baylor Jones said, the spaces between them are huge. So even over the long life of our galaxy so far, the probability of any two stars have actually collided, as opposed to just coming close, is extremely small. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.